Here we go. Okay, since we are ready to start now. So thank you all for joining us to this serverless online event tonight here from Paris. We first want to thank our tonight's speakers, Jan Kui and Rita Kozlov. We will speak in a few minutes now. I also would like to thank the ServerlessDays organization team and the meetup group Serverless Paris, which is supporting the event tonight. And of course, we would like to thank all you people attending this online event because, as you know, we initially wanted to do an on-site event. But according to the COVID events, of course, we wanted to maintain something and to emulate and make the community spreading and discussing about serverless. Although we are all confined today. We want to remind that the ServerlessDays event are a community of events which are open to foster discussion about the serverless technology through various events in the world. And this is a non-profit organization. I would like to remind you that's an important point that in the same time during the whole event you can join the discussion on the Discord channel which has been prepared, so you can discuss and ask some questions there which will be discussed in the last part of the today's event. So do not hesitate to ask some questions, but please ask them in English because our tonight's speakers speaks in English. Well, I think I'm good. Avoid spam, of course. Please be respectful on this channel, of course. And now I just want to discuss the agenda. We will start with Jan Kui with his talk "Don't Try This at Home," which will discuss some learnings about serverless experimentation. Jan Kui is an AWS serverless hero and speaks in various meetings all around the world. And in the second time, we will have the opportunity to welcome Rita Kozlov, which is Cloudflare's product managers, and which will discuss the future of serverless, discussing the edge topic. So it will discuss the Cloudflare's workers, which is a non-edge serverless solution changing the web stack. And at the end of the presentations, you will have the opportunity to join a panel discussion. So it will be the opportunity for you to ask some questions to our tonight's speakers, and the discussion will be animated by Guillaume Letron. So please enjoy your evening, and I just want to finish that this is the first event, and we hope to see you joining the further events we will organize in some time. Have a nice evening. Please, Jan, your floor is yours.
Cool, thank you, Adrian. Can you guys see my slide okay? Hey, Adrian, can you guys see my slide?
We do say.
You do? Okay, cool. So in that case, let's get started then. First of all, I guess thank you everyone for joining us today. So I want to talk about, well, the topic says that don't try this at home, but really I want to talk about the value of experimentation and the need to do it tastefully. We should say that just because you could doesn't mean that you should, at least not when it comes to your production environment. But first, let's revisit one of the best films from the last decade, Inception, and customary spoiler alerts. Honestly, if you haven't seen this film already, the team needs to into structures, and to do that, they need to go through this really complicated process of bugging him in the real world, and then go into his dreams, and then a dream within a dream, and then a dream within a dream within a dream, and so on, so on it goes. And right at the end, the film leaves us on this edge and questioning whether or not DiCaprio's character Cobb was living a dream all along, and that he didn't actually reunite with his children, and it was all just a dream. Again, I'm doing the film a terrible justice here, but as you watch it for the 5th time, you start to notice a pattern that the Cobb, the protagonist of the story, and the DiCaprio's character, throughout the film, he was constantly telling people, don't do this, don't do that, and then he goes and does it himself. And when you consider the Dreyfus model skill acquisition, where you start at the bottom as a novice and you just do what everyone else is doing, then you discover best practices and design patterns, and you gradually gain an understanding of how and why these things work. And over time, you develop a sense of when to apply which pattern, for example. And then as you get even better, you start to mix and match them different patterns together to compensate shortcomings of one pattern with another. And you also start to learn to deviate from these patterns as you need. But it still requires a lot of conscious effort and planning, but at least you know how to do it. And by the time you become an expert, you not only have the knowledge, but you also have the good looks to go with it as well for being an expert. Your hair is all sleek, you got this nice suit and maybe a 6-pack if that's your thing. But because now you have transcended the rules, the guidelines and maxims, because you have an intuitive grasp of the situations based on your deep understanding, and you can use an analytical approach in new and unfamiliar situations as well. That all sounds great. And that's all what we want for sure, I'm sure. But how do we go beyond scratching the surface, and how do we figure out that having a dream within a dream is actually a thing, or that limbos exist and all the rules that govern them? How does one find out about these things? It's not like they are documented anywhere, which incidentally, neither are the features in the Cognito service in AWS. Well, I can tell you what's not going to help you here. We're not going to become experts by just doing the same thing every day. Einstein defined insanity as doing the same thing and expecting a different result. The same theories apply here, that true expertise requires deliberate learning, which is also echoed by other theories on learning and expertise, including Malcolm Gladwell's book, Outliers, which famously said that it takes 10,000 hours of deliberate practice to reach the top of an ultra-competitive field, which unfortunately is often misquoted and misrepresented. And I see crap like this all the time that confuses mastering your craft, that is being good or great at what you do, with reaching the top of an ultra-competitive field. And it counts every hour of your working day towards the 10,000 hours, which is just not how it works. If all I do is kick a ball against the wall every day for 8 hours a day, I don't suddenly become Leonardo Messi or Ronaldo after 5.5 years. Because the 10,000 hours is for deliberate practice, practicing specific techniques, tricks, not just repeating what you do every single. And practice learning should also be challenging as well. It should make you uncomfortable. It should challenge your fundamental beliefs of how things actually work. And it's often driven by your curiosity to peek behind the curtain to see how things actually work. I mean, how does one turn himself into a pickle? And Cobb did this by spending decades in limbo. So to become an expert, we need to go off the road and start walking into bushes and discovering new paths. That's how we gain deeper understanding of how things work. So my name is Yan Cui. I'm an AWS serverless hero, and I've been using AWS to build pretty scalable systems for more than 10 years now. And the last couple of years, I've pretty much focused on serverless, and including migrating a social network to run pretty much entirely on serverless with Lambda. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications that make it really easy for you to troubleshoot problems, even when you have this really complex and connected serverless architecture. The other half of my time I spend working as an independent consultant, where I work with companies all around the world and helping them adopt serverless successfully through training, advices, and sometimes helping teams build products as a hands-on contributor. In my free time, I like to produce a lot of content, from blog posts to video courses to books, and I publish a few with Manning. And this month, I'm also running a hands-on online workshop called Production Ready Serverless. We just started this week, so you can still join without missing out on any content. So in terms of the value of experimentation, provided that you share what you learn afterwards, it can create an immense amount of learning and value to both your organization and to the wider developer community as well. You can save your colleagues from making poor decisions based on incorrect assumptions and poor understanding of how some services work, and having to undo their mistakes months later and then re-architect things. But don't just throw your experimental code or POCs straight into production as they are. That's just asking for trouble. If it's done tastefully, experiments can be very valuable to everybody in and outside of your company. And they will be great for your career as well. If there's one career advice I can share with you, it will be to do experiments, blog about them, and speak about them at user groups and conferences. It's the same advice I gave to many of my colleagues at the Zone and beyond. For example, Simon, a good friend of mine now, built a very scalable WebSocket system for the Zone after trying out some of the services available in AWS and found their shortcomings for our use case. So he wrote about the experiment, he wrote about a service he built, and was invited to speak at multiple events about the whole journey. But don't stop there. There's always more for you to learn, and there's always more others can learn from you as well. And that's my talk. No, not really. You came here expecting some serverless stuff. So here are a few experiments I've collected that I find really interesting about Lambda. For example, did you know that you can run headless Chrome in Lambda, which started off as an experiment and it was kind of clumsy to do, and then came a serverless framework plugin that make it actually quite easy. And when you think about it, there are actually lots of legit use cases for this, like scraping web pages or generating web assets dynamically. For example, one of my clients generates these hand-drawn animations that you often see on YouTube, and they do it through headless Chrome running in Lambda. And increasingly, I'm also seeing people doing end-to-end testing for front-end web pages and even visual testing as well, all driven and ran inside a Lambda function. And for anyone who's constantly reminding you that there's still a server behind the Lambda, which is A, besides the point, but also B, the opposite can also be true, because guess what? You can also run a server inside a Lambda function, so you can have a server running inside a function, running inside a Lambda, running inside a function. Server. See, it gets confusing there. And as a point, quite and used in several that I know of, machine learning and deep learning research projects at universities. Some even open source the tooling that they use for that as well, which I thought was quite interesting. And then there's this guy called Tom Wallace, who's always talking about applying meta-programming techniques to Lambda. And meta-programming is basically when you write programs that write themselves. For example, when you look at Lambda function, a function can have access to its own code. It can deploy updates to its code and configurations like memory, timeout, etc. And it can even update its own event source mappings to change the batch size from kinesis or other similar configurations you find there. So a function can actually self-optimize on the fly by, say, adjusting its memory and timeout dynamically to deal with back pressure without having to require some human operator to do an update. And it can also deploy updates to itself. Tom, for example, had a use case where he needs access to ultra low latency cache, and the cache is kind of bulky, but only changes once per day. So he can either load this big blob on every single cold start, which has execution time, or he just bakes the cached value into the code and has the function redeploy itself once per day. It's not something that I recommend for pretty much anyone, but for his specific use case, it was actually an ingenious and efficient solution. Other examples also including using having those static, slow changing values that you may find in environment variables and being able to dynamically change them as well. And for the more sort of outlandish ideas, you may also can think about, well, can we in that case auto-generate API endpoints for those multi-tenant SaaS systems, or more practical ideas like we can have functions that can self-optimize or self-heal. For instance, I worked on a client project where we built a self-healing kinesis function that adjusts its batch size based on the latency and error rate from the downstream system. And we even had the built-in circuit breaker to stop the kinesis trigger altogether. And then every 10 minutes, we're going to re-enable it and at a batch size of 1 to see if the downstream has to recover from whatever error it was having. This was necessary because the downstream system is this third-party banking system that would blacklist us if we ever access the APIs too aggressively. And being blacklisted in this case is basically game over for the business. So metaprogramming is very clever, but there are some obvious dangers involved here. First of all, it's just so much more complexity. I mean, having code that writes itself, good luck with that. And by design, their behavior is also mutable. So how do you even write tests for that? And now functions can update themselves, which is bound to alert any security people you have in your organization. And by the way, forget about having immutable infrastructures because the functions are just going to update themselves. And if that's not enough, turns out you can also just SSH into your Lambda function. Of course, that's not a thing out of the box and requires some pretty clever back tunneling from a Lambda function to connect to a SSH server that you run locally and expose publicly through ngrok. But where there's a will, there's a way, right? And just for fun, some folks and to see how Lambda is actually really secure. Some guys at lambdashell.com posted a bounty on to challenge anyone to do damage to a function that you can access through SSH tunnel. The funny thing is, the Lambda function was fine, despite the whole SSH shell being exposed, but they left the S3 deployment bucket public. So someone hijacked the site and took them down. So the moral of the story here is that when it comes to security, don't just look at your functions, look at the whole things holistically. Right, so continuing on, a girl from Epsilon did some really interesting reverse engineering of the Lambda execution environment and found that there's this bunch of native methods that you can, or libraries that you can bind to and then run from your function. That we then invocation bits. And so if you have a long running process, you can do this in one invocation from the perspective of your code, but without having to use tricks like writing recursive functions. But I stress again here that you do still pay for them as separate invocations. Again, some pretty obvious danger signs here that since you're relying on implementation details that can change without notice. So if you're actually going to do this, then know that one day you would just break, you would just stop working when the Lambda team makes a change to the environment. And here's another fun one. For anyone who wants your machine and the code that's running inside the Lambda execution environment, which understandably means that the invocation is just going to hang while you step through the code one line at a time. This is again very, very clever, very cool idea, but there are some pretty easy, much easier way to debug code. For example, using the SAM and the serverless framework, they let you invoke functions locally, and you can attach a debugger there. They don't let you run against a live function, of course, but you can only do that in a very controlled environment anyway, where you need to really up your timeouts to give yourself time to step through the code, and there's no one else using the system at the same time. SAM and the server framework can use Docker Lambda project to give you a Docker image that basically matches the actual Lambda function runtime. So you can already execute and step through your code locally while running them in the AWS-like environment. And along the sort of whole Lambda as a server ideas, turns out you can also run a TCP IP stack by the fact that logs TCP IP, you can change that endpoint. But as you can see, it's really, really slow. So really, there's not much practical application here. That is not that I can think of. But it's open source, so feel free to check it out if you want. So those are some of the fun, but maybe not so practical experiments I've seen. They do expose many of the underlying implementations details of Lambda, and we can learn an awful lot about the platform through them. There are also many other experiments that have yielded practical actions that help us improve the performance of our code. For example, I did a bunch of experiments with a client of mine measure the cold start for Lambda functions by looking at the setup time, which you can roughly think of as the time that Lambda takes to find a space in the fleet of EC2 instances to allocate a container to run your code before you can even run initialization on your module, and which together is basically what we would call as, consider as the cold start time for your function. And it turns out that initialization is always performed at maximum CPU. So memory actually has no measurable impact here, and we kind of omitted it. Well, we kind of omitted it from the graph here. And also, more importantly, B, more memory means taking longer to allocate the container, presumably because, well, you've got a fleet of EC2 instances, so someone asking for 3 gig of memory, it's going to be harder for you to find a gap in the resources that fits that 3 gig in. What that means is that overall, your cold start is probably going to take longer if most of it goes towards the setup time. Of course, it's also worth mentioning that the whole experiment was done quite a while back. It was over 12 months ago, so these numbers are likely quite different now. And if you want to optimize the performance of a function, you need to measure it against realistic workloads. It could be that you're also doing more CPU-intensive work. So even if setup time is longer, there's just significant saving in the warm execution time. So you still want to use high CPU setting regardless. And you can't really talk about memory allocation, optimization, without talking about Alex Casabone's power tuning Lambda tool, which nowadays you can also just run as part of the CI/CD pipeline, which I've got a blog post to show you how to do that, to make sure that you're always running on the most optimal memory setting for your workload. And while we're here, have you wondered how expensive using the AWS CK is and how much cold start time it adds? Because remember, during cold start, Lambda needs to initialize your module and require your dependencies. And turns out, when you require the full AWS SDK, it adds over 100 milliseconds to your cold start time for Node.js functions compared to when you require only the DynamoDB client, assuming that that's the only client you need. And if you use Webpack for Node.js functions, that is, then you can also even improve your cold start time even more, because most of the time in the initialization phase of cold start is file system calls to load all those modules. So Webpack collapse everything into one big module for the function, and hence eliminating any and all those file system calls and making your cold start go faster. And the last experiment I want to share is the fact that HTTP Keep Alive is not enabled by default for Node.js functions. And through an experiment, I found out that if you just set this environment variable to 1, then you literally save yourself about 20 to 25 milliseconds for every single AWS CK operation. So talk about the simplest optimization you can do ever. And this applies to cold starts as well as to warm starts. So those are just some of the sort of things I learned through experimentation with Lambda and AWS. The great thing is that all of this pretty much didn't cost me anything, because running experiments on the cloud is just so cheap, especially when it comes to serverless, because you only pay for what you use. And we have come up with so many useful ways to improve the way we build serverless applications, because we've been doing all these different experiments. And they also help us gain a much deeper understanding of how the Lambda help up the ladder. So remember, you want to do these experiments very tastefully. So do it at home. Maybe don't do them at work. At least not throw your experimental code or POCs straight into production. And remember that learning itself can often be its own reward, and sometimes probably the only reward that you should be looking for. So that really is the end of my talk. And here's a list of links to the experiments I mentioned in this talk. So feel free to check it out afterwards. And as I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how serverless can help you and your organization go faster, or need some help just upskilling your team, then let me know. Go to theburningmonk.com/hire me to see how we can work together. And I'm also running some public workshops this year. So that's going to teach you everything you need to learn, to know to build production-ready service applications. And I'm actually running one instance of it right now as an online workshop, and you can get 50% off with this code. And you can also get 20% off my video courses with this code as well. And so with that, thank you guys so much for your time, and stay safe, everyone.
All right, can you guys see my screen? Let's see, is that a yes? Great. Okay, so hello everyone. My name is Rita. I'm the product manager for Cloudflare Workers, which is Cloudflare's serverless platform. And today I'll be talking to you about what I believe to be the future of serverless, which is isolates on the edge. So if all of those words sound to you like a bunch of tech word soup, don't worry, we'll be walking through it and I'll explain to you guys exactly what it means. So we're all here to talk about and tweet about maybe hashtag serverless, right? And at the end of the day, what that word really means is that developers should be able to write more code and focus less on ops, right? Bringing up servers, scaling them up, scaling them down, all that kind of stuff shouldn't happen. In fact, if we're successful in our mission and serverless really is the future of compute, then the next generation of developers should be asking themselves, wait, why is this thing called serverless? What even is a server? And it should be this way, right? Really, really easy from the beginning to the end. So the whole point is that it's easy to get started. You don't have to go buy a server. And it should be easy when you are done with your project as well. The scaling should be seamless as well. And the reason that we care about this is because that's what allows us to deliver value to our customers. So at the end of the day, your customers really don't care what kind of infrastructure you're running on, right? What they care about is that you're delivering them features and products that they like, and that they're able to access them in a way that provides a good experience to them. So I have a question to ask, and it's, are we there yet? Are we really living the serverless dream? And to answer that, I'm going to take us on a little journey that we've gone on so far to get to today, right? So it used to be that to bring an application online, you had to go out and buy a physical box. And thank God we don't have to do that anymore, because it took months to deploy a single application. The next iteration to that came with the invention of virtual machines, which meant that rather than going out a box for every single application that you had to run, the second and third and fourth applications were much easier to run and took only weeks by comparison, because the machines were virtual rather than physical. Then the cloud came along and said, stop buying boxes altogether. You shouldn't have to worry about that. A provider is able to take care of that for you, which took the time to deploy down to hours or minutes. But the cloud is not exactly serverless, right? I know that because the cloud has existed for well over 10 years, but the word serverless is relatively recent. I think we've been using it for 4 or so years. So why isn't the cloud serverless? I know it's rude to answer a question with another question, but I think the answer to why the cloud is not quite serverless is that you really can't just write code today, right? You might be thinking, we have functions. That's kind of like writing just code, right? I can log into my console and I can write my function. And that allows you to just write code in the sense that you don't have to do a bunch of stuff up front. But that doesn't mean that after you've written your code, you're done. How do I know that? This tweet is a very good illustration of how I know that, right? It says, I ping my Lambda function every 15 minutes to make sure that it's warm. And then it asks, isn't that just another server? So in a world where we really didn't have to worry about infrastructure, you shouldn't be thinking about pinging your Lambda functions. They should just work. Why is that happening today? And the reason behind that is that the world is still physical and the internet is still physical, right? And to me, it really came to life when one day I saw a sticker on someone's laptop that said, the cloud is just someone else's computer. And actually what we know today to be functions are actually someone else's containers. Jan touched on this earlier, right? When you hit a Lambda function, it takes some time to instantiate that and initialize that container in the first place. So what we call the cloud is really most of the time a data center somewhere in the world. Most of the time, kind of randomly, it's in Virginia. And your customers are all over the world, right? So something here doesn't seem quite right. And this results in not always the best experiences for your users. And it takes up more time for developers to get started on their projects. All because they have to worry about all of these other things as well, right? Scaling your functions, if you want to service customers, not just in North America, you have to scale up other regions, you have to route your traffic to the right places, there are all these hacks to make sure you don't hit cold starts. And I think we can do better than that. But actually, it's not all bad. There have been a few trends that have been kind of putting us in the right direction. In parallel to the rise of the term serverless, another term that's becoming really, really popular is this thing called the Jamstack. And the Jamstack is basically a new way of thinking about how to build applications through using JavaScript, APIs, and markup. And the intent behind it is to simplify things so much, and the reason that it goes hand in hand with serverless is that it allows you to worry a lot less about your infrastructure compared to something like the LAMP stack, right? So here's a great example of a traditional LAMP stack type workflow to a Jamstack type workflow by comparison. So traditionally, let's say you wanted to get something like a simple CMS like WordPress up and running, right? The developer would write and deploy their little WordPress program, and then the customer would go to mywebsite.com/about to load a seemingly simple static about page. And every single time the server would produce that HTML on demand as if no one had ever asked for this about page before, which is a very inefficient way to go about things. Now, there have been some technologies like CDNs that have allowed you to cache static assets, but sometimes you actually can't cache the HTML, which has created a lot of issues, as well as introduced some security vulnerabilities over the years. I know this because I've helped many a customer deploy the Cloudflare WAF to patch them, and as I mentioned, performance problems. So how is this different with the Jamstack? Well, the developer would instead use a static site generator, so something like Gatsby or Jekyll, to generate the website and all of its assets statically. They would then deploy them still to a server. And then when a client would visit the website, it would go through the CDN, it would fill the cache of the CDN so that future customers that are accessing the same page don't have to hit the same pop, but at least it doesn't get rebuilt every time. So already we have a huge improvement. And if there were dynamic elements that you wanted to load for that page, you can call different APIs from the client side. Which is the A part of the Jamstack, right? So the pros here are obvious. Performance is much better, security is much better. Cons are you lose some functionality. So a lot of sites today are trending in a static direction, but they used to be able to be dynamic, and relying on APIs being called from the client side creates this next issue called client side bloat, right? So it means that now devices have to hold all of the state and are themselves responsible for rendering all the dynamic elements of a page. And even though it's not quite the same cold start as the one that it takes when a new container is initialized, on that original request, you still have to travel to a single origin to fetch those assets rather than having them directly near the end users. So I think this is really good, but I think we can do even better than that. And what that looks like today, just to provide you with a really concrete example, is through the thing that the Jamstack is missing is the addition of the edge. And I'll talk in a second about what exactly that means. But what it actually would look like and looks like is that a developer writes code and develops their assets they want for their websites. They then should be able to push them directly to the CDN or directly to the edge network that's running near their end users. And the rendering should all be able to happen there so that by the time that it reaches the client, when a client makes a request to those assets, they are served a fully live and well page from somewhere nearby. So that is what Jamstack on the edge is, but let's talk a little bit more about the edge. I often get this question, especially I used to run the onboarding session for many new Cloudflare employees, and they would ask me, okay, I get that it's called the edge, but the edge of what? And I think the answer to that is traditionally there was an origin server, right, and there's a client. And the edge really pushes the edge of how close can you get to the client device without actually running the code on the client. And the way that you can do that is by placing data centers all around the world so that you're always milliseconds away from your end user. So a few years ago, we launched Cloudflare Workers, and Cloudflare Workers allows you to do exactly that. Run code just where your end users are, rather than having to send your customers all the way to an origin running somewhere else. And Cloudflare Workers runs out of every single one of our data centers. So Cloudflare Workers, as I mentioned, is code that is able to run on the edge. So how exactly are we able to do that? Well, a few years ago, we started thinking about this problem because we were running security and performance services for our customers. And it very quickly became clear that there were so many things that they wanted to customize that the ultimate way to allow them to do so would be through letting them write code. And we started thinking about how do we solve this problem? And one of the ways that you can solve this problem is by putting containers on the edge. The problem is that we offer performance services, and introducing a cold start in the middle of a CDN that's meant to make your performance faster is not exactly a great solution, right? So we were looking for an answer, and we started looking as close to, and we realized that the answer was just in front of us. It was directly in the browser through something called the V8 engine. So V8 is what allows you to run client-side JavaScript in Chrome and has been battle tested for many, many years. Now, unlike a container or a virtual machine, a V8 isolate allows us to, already has the runtime preloaded. So every time you run a function, we don't need to restart the whole container. We're able to load up just the function that you're trying to run, which is what results in the negligent or non-existent cold starts, and allows us to do this a lot less expensively, right? So one of the premises of serverless is that you only pay for what you use, but realistically, you're not using the entire runtime that's spun up for you every time. And with isolates, we're able to do just that. And through the V8 engine, we're able to support multiple languages beyond just JavaScript using WebAssembly, which is what the web has been moving towards in terms of multi-language on the client side as well. So what are the applications of being able to run this code on the edge? Well, the first, as I mentioned, is web development, right? So there have been many different evolutions in web development, and being able to run your web application as close to the end user as possible has sort of been the missing piece. A few months ago, we launched our product called Worker Sites, which basically allows you to host a static site directly on our edge rather than hosting it somewhere and then having the edge pull it from there. And we saw really meaningful performance differences there, right? So Worker Sites compared to other static site providers, due to running so close to the end user, gets significantly better performance, not just in North America, but all over the world. one of the reasons that this is really important is that we're seeing the demographics of who is using the internet shift as well. We're seeing a lot more and more users in Africa and India. And whenever these users are coming online, it's rarely through the smartphones that we have access to. A lot of the time, it's cheaper phones that aren't able to, first of all, handle all of the client-side logic that you're putting in them. But secondly, don't have the power to wait on a network request to travel all the way to an origin on the opposite side of the world and then back. So we believe Cloudflare Workers to truly be serverless because it allows you to get started really, really easily. So you can get a function up and running within a couple minutes. So you got the ops taken care from you from the beginning, but then also all the way to the end because it seamlessly scales and is really performant out of the box. And this goes well beyond the Jamstack. I've been thinking about this a lot because I've been at home a lot, as we all are, right? And it's been true that while everyone is in lockdown, the internet is really your window into the rest of the world. So having your web application running performantly is really important. But I think over the next few years, we'll also see an explosion of having other devices that we're constantly connected to, whether it's a smart refrigerator, self-driving car, or a smartwatch. You don't want it constantly talking to a server that's on the other end of the world. You want those results, you want that information immediately and as quickly as possible. And I think compute on the edge is the way that we're going to be able to make that happen. So the edge is the future. And first of all, it's the future for developers, right? Because it allows them to worry only about code and become much more efficient at what they're doing. But also for consumers, because it creates the best, fastest experience for the end customers. And developers shouldn't have to choose which customers they care more about, right? Your customers in North America or your customers to Australia. Your application should just be fast out of the box everywhere. So thank you, everyone.
Thank you. Hi, everyone.
Adrian, I can't hear you.
Yeah, Adrian speaking, and we don't hear him. So Adrian, do you have something to say? Can we hear you? Oh, no. So sorry, Adrian. So I'm Guillaume Neton. I'm here to be the animator of this panel questions. So you can ask any question inside the YouTube comments or inside Discord. So don't hesitate. We have only one question right now, but I'm sure that there will be other in the next second. So thank you, you two, Jan and Rita. It was really awesome talks. Really, you give me a lot of questions, a lot of remarks, etc. So really cool. Maybe I will begin with you, Rita. You talk about all the age is the future, but you didn't talk about maybe the green efficiency and all the stuff we talk these days. At Cloudflare, did you try to learn more about is it more green efficiency, about the power consumption and stuff like that? Do you have some stats to give us, because it's a main subject right now? You are mute.
So I don't have stats to share, but this is actually not off the top of my head anyway, although there is a blog post I think that we wrote last year for Earth Day around actually one of the reasons to move towards the edge is due to the higher efficiency and thus the greener nature of it. And there are two ways in which you get those benefits. So as I mentioned earlier, one of the benefits of isolates is that the runtime is preloaded. We don't have to spin up a new one every single time. So already you're able to squeeze in so many more workloads into a smaller amount of servers and using up less power. The other way in which I think this will have a really positive effect is in that by running compute so much closer to the end user, you're not having to wait on all that network and thus end up using up battery life or any additional power just on that wait time. And that those hundreds of milliseconds on every single request really do add up to compute that your machine is using up.
Yeah, cool. And Jan, just a quick question, the beginning. Did you try to use workers, Cloudflare workers right now or not?
So what's the question?
Did you try the Cloudflare workers, what Rita talked about?
Oh, yeah.
Did you try it?
Yeah, I tried it. Cloudflare Workers is great. I think it's an amazing product. Yeah, if anything, I wish the Lambda Edge is anywhere near as good. I guess the only problem I find with Cloudflare with most organizations is just that there's another vendor. You got to sign up, which means you have to go through all this bureaucracy of signing up vendors. If I can pay for it with my AWS credit account, then it's so much better. But yeah, Cloudflare Work is amazing, and also quite like the fact that they've got a KV store and all of that as well. I think that's probably the next frontier that we really want to see more data and compute in one place at the edge, so that again, cutting out all those round trips, adding latency, and doing all these different things that you have to do in the origin.
Cool. And someone asked you about how can you give you a right atmosphere to experimenting in a workplace. I see that you begin to answer, but can you share? Can you share it?
Yeah, sure. I think for the whole organization-wide, you probably want to think about doing regular hackathons or game days or whatever you want to call it. And the reason why you want to do this is because developers get bored. So if they end up doing the same thing all the time, what they're going to do is, oh wait, I heard about this new weird thing that I want to try out. I have nowhere to try it out, so I'm going to try out my project, and that goes into production. So giving them like organized way to release some of that pent up creative energy also just helps keeping people away from doing silly things in production. But I was working for a games company where we used to run the basically like a game day, game hack day, whatever you call it, every month, and we actually end up building a lot of product out of the ideas that started as a hackathon. On a sort of more top team level, you also want to give people time to do the research, time boxing, of course, especially when you find yourself sitting in a meeting, you're designing your architecture, and oftentimes you find yourself making a lot of assumptions about what you're going to do based on if this feature works like that. So rather than making those assumptions and then going and building things straight away, give yourself time box the chance to time box some experiment to figure out how does that thing actually work. As you see lots of the posts on the internet about Lambda is terrible, it's more expensive, slower, and all of that. And then you read through it, it turns out they're just doing something wrong, and they're doing things that based on poorly understand the concepts and poorly researched and assumptions. Which if they spend more time researching and less time doing stuff, right away, it would be far more efficient.
Okay, cool. And for you, Rita, you say that you begin to work on workers because some clients ask you. And was it already in terms of, did you begin to work on some stuff at first, like Jan say, just like some experiment and stuff like that? Or did you try to focus on some clients? And today, what are your biggest clients, and do you have some big clients who are using workers or not?
Yeah, so actually, it's kind of a funny story that relates to my personal background at Cloudflare and why I personally ended up working on Workers. But actually, when I started, I was a solutions engineer, so I was helping onboard these big customers. And as you do in the earlier days of a company, we were doing a lot of effectively snowflaking, right? So a customer would come to us and they would say, okay, I want to be able to cache this asset, but only if this header is present. And then if it's coming from this particular country and there is no header, then I want you to send a redirect instead. And a part of my responsibilities was to write this code. It was written in Lua. And it would get released as a part of our weekly, like we are now deploying the software that the edge runs, and there's a little exception that says, like, if this is the customer, then take these actions. And one of the paths that we started down at one point was like, what if we allowed developers to write Lua on the edge, which I'm glad we didn't take that path. JavaScript allows us to target obviously a much bigger audience, and I actually think we'll probably allow people to run Lua pretty easily at some point soon, because you can compile it to WebAssembly. But there were a bunch of different ideas definitely thrown around as we started thinking about how do we allow developers to write code on the edge, and even V8 was something that we weren't sure about at first, like how exactly is it going to work, and then we found the service workers API, which actually works quite similarly to how the edge works, right? In that it receives requests and proxies them and returns the responses, or it can just return a response. So it took quite a bit of experimentation to get there. To answer your later question, in terms of big customers using us, so a couple of my favorite examples that I think will be pretty familiar to this audience are, first of all, NPM. I think most people here played around JavaScript for a while. If you've downloaded a package sometime in the past couple of years, that package was probably served to you by a Cloudflare worker. So they have been really large adopters. The other customers that many of you guys are probably very familiar with are Discord. And for both of these customers, it's been really interesting to see the evolution of their usage from, oh, I can use this kind of for the original intended use case, which is like, oh, I can modify a header or customize my caching, to, whoa, actually, I can like move my entire front end to this. And what we see at these companies is once developers start using it, they realize what a superpower it is, to where it becomes the first tool that they reach for when, like, oh, I have a problem, let me see if I can solve it with a Cloudflare worker, is kind of a joke that we've heard a few customers say as well.
Cool. And just to at the end of Jan, he says that you don't have to innovate at work, or maybe not to try it at work. But when you are working with workers, Rita, what is the journey? How can we have a staging environment, a dev environment, something like that? Because we have to try before going prod. So what is the developer journey on using workers?
Yeah, so the developer experience and environments have definitely been a really big focus for us, and probably the biggest area of growth for us of what we've accomplished over the past year or so, and what we'll be working on this year. So earlier this year, maybe even late last year, we introduced Wrangler Dev, which is effectively an edge-based development environment. So actually, to take another step back, last year we introduced Wrangler, which is the official CLI for Cloudflare workers. So it makes deploying a worker or website from a template really, really easy. It only takes a couple seconds. And by running Wrangler Dev, you're able to spin up an edge-based development environment that feels exactly like a local development environment. So you can effectively develop locally. You will see all of your requests go through localhost on port 8787, or you can customize it. But that's like the original testing that you can do. And then similarly, through using Wrangler, you can configure multiple environments. So you can have your variables for your staging environment separate from your variables for your production environment. And we have actually, we're working on making all those things even better right now.
Cool. Yeah, you talk about the skill acquisition. I didn't know about all these stages you talk about, but it's really cool. I know about the 4th stage of competence. That is an old pattern to know how what are the stage you take to be an expert or to know something. And in your case, how many times did it take to you to be just like an expert in the serverless, or how many time does it take to you?
I have no idea if I'm an expert, but I definitely know I'm quite proficient.
Yeah.
Well, how many times I have no idea. I don't think there's any exact science to it, but when you look as good as Leonardo, I think you know.
Okay, and what is the craziest experimentation you have done? What is the things that is really something really crazy that you see?
I mean, some of those experiments are listed. I think the craziest ones are the ones that, like, running Docker inside Lambda. I think someone managed to run the Kubernetes inside Lambda as well, which I thought that was pretty wild. Not because something useful, but because you could. But other than that, most of the experiments I do are kind of limited, quite small in terms of, okay, I wonder how this feature works. What can I sort of make it do? But I try to sort of focus on something that's a bit more practical. So I do a lot of things with some meta programming stuff to see what I can what I can do there. But again, do it in a specific, for the sake of learning, not for can I use this on a project.
Cool. And how many time if you have an unlimited time or limited time, I can say, how it's your part you will innovate and some parts you will do your job. If you can give us some kind of insight, maybe 20% of your time to innovate and 40, I don't know, because we can't innovate every time. Oh, we lost.
I think it's cut off there for a bit. Yeah, I think I probably spend at least a couple of hours a day for the last maybe 10 years doing things, and I've done about 10% time. Not work for a company that dedicates a certain amount of time, but certainly as part of my job, a lot of times we have to try out new services. So we got to do some of that experiment work in terms of we want to use Lambda thing that just came out. What can we do with it? So there's some sort experiments they can do at work, but I try to most of what I do just I wonder how does that thing work, and then try to design an experiment, try to apply the scientific method, know your hypothesis, define the criteria, and then you just build something and see if it works the way you expect them to. It's the same process people go through with things like chaos engineering and things like that. It's just yeah, I don't have any guidelines on how much time I spend, but certainly just I've got a really long list of things that I'm curious about, and I try to find time to do them when I can.
Yeah, cool.
But if I may, one of the things that's been really worked really well for us is giving at the beginning of projects, giving engineers time to experiment and prototype as well, because sometimes especially as a PM, right, you have a problem and then you have a specific way in your head of what the solution will look like. But actually, if you give people the chance to experiment a little bit and have a chance at looking even more in breadth at what the solution space looks like, they will come up with stuff that you never even thought of. And actually, that was the way that Wrangler Dev ended up being developed. So we had kind of one project in mind of what the local testing and development will look like. And we gave the engineers some time to really take it in. And the result was much better than what any of us originally thought of.
Yeah, that's what I said earlier about spend 2 weeks researching, 2 days doing work, much better than the doing 2 weeks of work and then 2 days research.
Cool. And we have a question because we talk about a lot about development and experiment, but when we are in production, there is some kind of things we can miss. It's security, and some people are asking about security when we are on the edge. How do you manage it? What is the secure environment?
I would treat security on the edge no differently than securing an origin. Actually, one of the nice things about Workers specifically is that it's a we started out as a security company and providing DDoS mitigation and a web application firewall. So once you've built your app with Workers, enabling all of those security features is really, really simple. We are constantly updating, the idea to us is that we should take care, just like we take care of your infrastructure, we should be able to take care of the security for you. So we're constantly updating V8 to make sure that it's on the latest version and contains all the patches for the latest vulnerabilities. But we've also found that actually the latest paths of web development are less prone to security issues in the first place. So, for example, building an application in React makes it much harder for someone to actually cross-site script your website than old PHP applications.
Yeah, of course. And something that nobody asked, but I'm asking myself. Can we see tomorrow? I don't know when, but even more at the edge. Maybe in France we have a lot of box, and it's quite powerful computer on ARM, but it's a computer. Can we see even more software inside my box? So that maybe I go on the website on Facebook, for instance, and it say, oh, you can be even faster by installing it on your box directly, one button, and can it be something possible, maybe with WebAssembly or something like that?
So one of the ways that we can make you faster is by moving the box closer to you. And by moving your application to Workers, you can definitely do so. Obviously, you're not going to be able to do that overnight. So one of the things that we've seen is that customers end up setting up a Worker as a proxy and then chipping away at moving parts of their application to the edge. But in terms of making your web faster on the client side, right? You have your computer and you have your phone. Cloudflare is starting to get into that space slowly. Some of the products that we've released recently that help with that are our 1.1.1.1 service, which provides the world's fastest DNS resolver. And if you think about it, every single website that you go to, the very first thing that you do is a DNS resolution. So being able to accelerate that already makes a huge difference. The other thing that we're able to do, especially on a mobile phone, if you have the 1.1.1.1 and Warp app installed, is accelerate many of the connections that happen between the phone and the app itself.
Cool. And we have a question also for you, Rita. And how Chrome Service Workers implementation within SPA is different from Cloudflare Workers? So.
Sorry, could you repeat the question?
Yeah, so all Chrome Service Workers implementation within single page application is different from Cloudflare Workers.
Yeah, so
it can be a tricky question.
Yeah, I'm not sure I still fully understand the question. So the service workers are different. First of all, it is confusing. Let's unpack this. It is confusing. So sometimes people talk about service workers and they conflate them with Cloudflare Workers. We use the same APIs, which is why we kind of reuse the name, but they're certainly not the same thing in that one runs in your client and the other runs on the server. But in terms of the APIs themselves, we try to make them as similar as possible. So there will be some discrepancies because as we started, working on them on the edge. Some of these, it's effectively an analogy, right? And some of these analogies don't translate directly. So for example, the cache API in a service worker that runs in Chrome will work a bit differently when you run it on the edge and you're not writing to like the computer's local memory, but rather to the edge cache. So we had to be really thoughtful there. And any way in which our API differs from the spec, the service worker spec, we generally document that pretty heavily to help disambiguate that confusion.
Cool, really cool. And Jan, I was asking myself, because you talk about a lot about some crazy experimentation and really cool one, but did you know if one of this experimentation changed a product because one experimentation just gives some more insight about what is possible on even the product, AWS or any other people that are doing some product, if an experimentation can change the product in a way that wasn't expected at the beginning? Don't know if you are here. Oh, I think we'll...
Okay, I think I caught the question there. So I know for sure that that experiment about the running debugger live against the live Lambda function from a Claysmith. So Thunder actually released a new feature recently that lets you do that, but it has all the sort of same constraints, but they polished up some of the security aspects of running that node debugger inside the live Lambda runtime and make it as like a product feature. Just one instance, and I know there's some stuff happening, I think, with the sort of TCP/IP stack thing. That there's some experiments around how to turn that into something actually useful. Not sure where that is, or whether or not I can talk about it. But but some of them has turned into something, some useful things. Probably not that many.
Okay, cool. And Rita, I have a question, because maybe I missed it, but did you know if there is some kind of standard, because you talk Cloudflare Workers as a really cool product, but did you know if there is a standard or some things that can be the same for all the industry? If the solution became some kind of big thing, or anyone is doing it, maybe we can hope to see a standard doing. And do you know if there is some people speaking about it, or not right now? Maybe specification.
Standard specification for running code on the edge specifically.
Yeah.
Yeah, it's kind of interesting. We've seen a few things emerge. So I know. Yeah. So one thing that we put out there is like the V8 isolates, right, and the JavaScript runtime. And I think a couple other companies have adopted that. So Fly.io was using the same thing for a while, and was following the same standard. StackPath was doing the same thing. The other standard that we're seeing emerge, or the other route that companies go down when they're starting to introduce edge compute, such as Fastly, for example, is in the direction of directly WebAssembly runtime. So their runtime is called Lucet. And it doesn't have the layer of JavaScript in front of the WebAssembly effectively. It's just raw WebAssembly on the edge. And so the good news is none of these are particularly different. We have a way to run WebAssembly as well, but I don't know that anyone is working specifically on a standard for what edge compute looks like on the edge. I think hopefully we converge somewhere so that I think it is important for people to be able to move their applications around to the provider that makes the most sense for them. Okay,
cool. And what is, I will ask you the question, and after that to Jan the same question. What is missing to Cloudflare Workers? In what is missing for you inside, and what is maybe the next step, on what do you want to see?
I think a few things. So the first is storage on the edge. So as Jan mentioned, we introduced Workers KV a couple of years ago, which is our key value store on the edge. But obviously, you're going to need a lot more than that to run a fully fledged application. So the different ways in which we can provide that and what that looks like is definitely something that we're working on and thinking about. The other types of things are different models of coordination, right? So the same way that like when the cloud emerged and AWS kind of the first products were effectively S3, right, for storage, and queues, and EC2, SQS, right? I think queues are definitely going to be pretty important. So I think storage and other primitives for coordination are what's missing to be able to build more use cases out of the building blocks that are provided for you. The other areas of improvement that we're actively working on that I think are true for all of serverless today are the observability aspect. So just because you've offloaded your infrastructure to someone else doesn't mean that you should get any less visibility into what's going on if you need it or if you want to debug. So that's the other foray in which we're headed.
Okay, cool. And Jan, what do you think can be missing inside the Cloudflare workers, for example?
Kind of no fair question because I don't really use Cloudflare workers. So
or maybe
really
maybe what can be the next step, or maybe the next experimentations that you can do, even not on Cloudflare workers, but what is the next things for you?
Next thing for me, again, difficult to say, but I like to see some of the use cases that people like to do in terms of some of the machine learning stuff on Lambda, which I've seen some use, some limitations around the limits around the temp file size. Look at temp file, for example. If you want to run a TensorFlow model, well, that model itself is going to be like 3 gig, so you can't really run that inside Lambda function, but I know a lot of people are trying really hard, and things like Apache, the other framework that the one that Amazon has been so pushing, I forgot the name of it now. They produce a much smaller payload size. So something that allows, I guess, the Lambda platform that opens up some of these limitations, at least having ways for you to load the bigger artifacts into your environments that some of the machine learning workloads can be run there. Because if you think about Lambda, what it is getting really cheap scalability very quickly, which is great for a lot of machine learning stuff. Because if you want to train a model, just spin up 10,000 Lambda functions instances, and there you go. You can blitz through some of the machine learning stuff really quickly. But right now, there's just a bunch of limitations that makes that really hard to do.
Okay, and we have a question also for you, but it's really, I don't know if I truly understand the whole question, but someone asked if you talk about experimenting with specifically importing AWS SDK clients rather than the whole SDK. And these people thought that the whole SDK was implemented within the Lambda layer, thus allowing me to require AWS SDK only within my developer dependency. Is it not the case?
The whole SDK was implemented within the Lambda layer. That's allowing me to only.
I truly don't understand. I'm not expert with the AWS SDK.
There's actually quite a few things here. One of the experiment I ran, which I didn't talk about, was how quickly can you load a dependency from your artifact from your package versus from the layer versus the AWS that's embedded into the Lambda execution environment. Turns out it's the quickest. Loading from the layer is the quickest of the three. However, if loaded from a layer, that means that you can't use Webpack to bundle it and remove some of the file system calls, which means that the net gain is probably better still if you use Webpack and shipping your own version of AWS. And in the case of the whole SDK was implemented within the Lambda layer. So even if it's loaded from the Lambda layer, remember it's still a file system call when you require, because most of the time they're spending that initialization part is just file system call to read files on the disk, which when you got AWS, it's got a gazillion number of dependencies on its own. That's a lot of file system calls, and that's what takes the time That's why you put an AWCK in your function. Even if you require the one that's embedded into the Lambda environment, that's going to add like 3 minutes, about 250 milliseconds, maybe something like that. Most of all of that is just file system call. Lambda artifact, it's probably going to help you as much as compared to if you just ship it your own and then require just a client you need and then use a Webpack.
Cool. I hope that this guy have his answer.
Yeah, AJ, and I hope that's what you're asking.
Yeah, too. But also don't hesitate. You give us your Twitter, so people can ask you directly on Twitter. I think after if there is some kind of precise question and they want a good answer. I think we are okay. I don't have that much question for you and people too, I think. Do you have anything else you would like to say or you can have missed?
Nothing from my side.
Cool.
Nothing from mine as well.
Cool. So it's okay for the QA questions. Cool. And right now, I would like to thank all the people that are right here, so all the attendants, but also to thank all the organizers of course of this event that can be possible. So it's really cool for them to also to ask me to come and to do this Q&A part. And all the attendees, all the speakers, thanks to you. It was really awesome to have you, Rita and Jan. Really, thank you for your talks. And remind that it's the first event of a series. So keep in touch. Don't hesitate to join the meetup, and you will see all the future events. So thank you to all of you for this wonderful time we get all of us. And that's it.
Thanks, everyone. Okay, bye-bye.
Thank you all. Bye.
Thank you.